All right, this video is going to be going over the basics of derivatives of polynomials and power functions. And so when we talk about the derivative of polynomials, first, we need to talk about the derivatives of constants. If you have a constant, then the derivative is going to be 0. The reason is, if you have a constant function, the slope of that line is 0. So the derivative of a constant is always going to be 0. If you have a polynomial, then we are going to use what we call the power rule. And you can also use this rule for power functions. Anytime n is a positive integer, then we are going to have a polynomial in that case. You can take the power, bring it down, and then subtract 1. So for example, if y was equal to x cubed, then I would say y prime is take the power, bring it down, subtract 1 from the exponent, and so 3x squared is going to give me the derivative. And so this is our shortcut right here. Okay, before that we would have had to go limit as h goes to 0 of x plus h cubed minus f of x all over h, and all the algebraic simplification would have gotten us to this point here. Okay, and so now I like to tell my students, you have earned your badge, you have earned the right to use the power rule, so we can go ahead and do that now. These next couple of rules just tell you that derivatives are what we call linear combinations. And so if you have x cubed plus 3x, let's just say, then you can just take the derivative of this first one, 3x squared, the derivative of this last. Now on that one, I would have to to the power of 1. So 1, bring it down. If you have a constant, I shouldn't have done a constant already. That's okay. But if you have a constant, you just keep it. So 3 times, bring the 1 down, x to the power of 0, and then you keep that same sign here. So 3x squared plus 3, and then x to the 0 is just 1, so this is going to be my derivative here. Also, anytime you have a line, like the line 3x, the derivative is just going to be the slope of that line. So anytime you need to take the derivative of something with an x, you're just going to end up with the coefficient in front. But another part of that one, like let's say in front of that x cubed, I have like 4x cubed. When I go to take that derivative, I just keep the 4 and then take the derivative of x cubed. So I'd have 12x squared as my answer. All right, here is another example. Let's say that I want to find the derivative of 2x to the 5th plus 7. So I'm going to say that f prime of x is equal to 2 times the derivative of x to the 5th would be 5x to the 4th. And then the derivative of 7 would be 0 because 7 is a constant. So I'm going to say this is 10x to the 4th. Let's find the equation of the tangent line to this quadratic at x equals 1. So it's a quadratic that opens up, and I want to figure out the equation of a line tangent to this graph at x equals 1. I could do some things to find the vertex, so on and so forth, things from college algebra, if I wanted to know more about this graph, but I'm just going to go ahead and plug in. I get -3 plus 6, I get 3 is my point. Now, when we did this last little bit, I would have had to then plug into, okay, limit as x goes to 1 of f of x minus f of 1 all over x minus 1, correct? No longer. I can say f prime of all x, I'm finding the generic form of this derivative, is the derivative of x squared. Bring the power down to x to the power of 1. I'm just going to leave it. minus, okay, the derivative of a number times x is just that number, plus 0, because the derivative of 6 would be 0. And so f prime at 1 would be 2 times 1 minus 4, or negative 2. So since that's a negative slope of a secant, or of a tangent line, excuse me, I know that I must actually be over here, or that the vertex of that parabola must be bigger than x equals 1. All right, so that equation, that line is going to be negative 2 for the slope, x minus 1 plus 3. Now let's extend this to all power functions. So everything we talked about was a polynomial, meaning your power was an integer, but the power rule works for all power functions, or x as the base, and we can raise it to a power. You do need to know some algebra rules on exponents in order to do this. We're going to rewrite this function with number or rationals as the exponents. So I'm going to say f of x, and I'm going to rewrite square root as x to the 1/2 plus cube root of x squared is x to the 2/3. And 3 over x squared would give me minus 3 over x squared, negative 3 x to the negative 2. Now we get really good at our exponent rules when we're working in calculus, but I really didn't do any calculus here. I just did algebra. I did algebraic manipulation to get this into maybe what we want to call derivative ready form. Now that I have a power, x to that power, I can bring the power down and then subtract 1 from the exponent. I can bring the power down and subtract 1 from the exponent. I can bring the power down and subtract 1 from the exponent, so that's negative 3. All right, let's just write this a little bit cleaner. 1/2, x then to the negative 1/2 plus 2/3, x to the negative 1/3 plus 6x to the negative 3. If I wanted to simplify this even more, then anywhere I see a negative exponent, that x needs to go into the denominator. And let's go ahead and write it in root form as well. So this is going to be 1 over 2 root x plus 2 over 3 cube root of x plus 6 over x cubed. Now we have some extension questions of this power rule. For what values of x will this cubic function have a horizontal tangent line? Well, remember, if you have a horizontal tangent line, the slope of that is 0. So I'm really asking in this question, when is f prime equal to 0? Well, let's go find f prime. That's going to be 3x squared minus 7 times 2x to the power of 1 plus 8, excuse me. Derivative of 8x is just 8. So f prime is 3x squared minus 14x plus 8, and I want to know, when is that function equal to 0? I need to factor this. And if I use negative 4 here and negative 2 here, then I do end up having negative 14 as my like terms with my x's and my plus 8. And so I get x equals 2/3 and x equals 4. That is where my derivative is going to be equal to 0. and that is where my original function will have a horizontal tangent line. We can also look at particle motion. So if I have a particle that's moving back and forth on a horizontal axis with time greater than 0, where this is the position at any time, then remember velocity is just the derivative of position. So I'm going to get 3t squared. I'm going to go ahead and just shortcut this and say minus 18t, because 2 times 9, subtract 1 from 2, plus 24. Another way to ask the same question that I just asked, but in a particle motion sense, is to ask, when is the particle at rest? Well, that's when velocity is 0. So when is my velocity equation equal to 0? Well, let's factor out a 3 first. And I'm noticing that I don't have two numbers that multiply to 4 and add to -6. So I'm going to have to use the quadratic formula. And I get 6 plus or minus, looks like the square root of 20 over 2. See, this is 4 times 5, so 2 root 5 over 2, or 3 plus or minus the square root of 5. Now, if I go back to my number line, because then my next question here is going to ask, when is the particle moving to the left? If I go back to my number line, I know that t always has to be greater than or equal to 0. And so I always like to check and see, like, are any of these times not in that range? Square root of 5 is going to be 2 something, right? Because it's close to square root of 4. So 3 minus the square root of 5 is still going to be a number bigger than 0. And my question is, when is the particle moving to the left? So I know, like, I'm starting at 0, and then one of my times my velocity is 0 is at t equals 3 minus the square root of 5. And one of the times I know my velocity is 0 is t plus, or sorry, equal to 3 plus the square root of 5. Some things that I might know about this quadratic is it's a quadratic that opens up and has 2 zeros. So over here, less than this x value or this t value on my chart, I would have a graph that's positive numbers, negative numbers between, and then positive numbers if you were to graph this, if you will, like on a coordinate grid, right? Which means velocity must be positive here, negative here, and positive here. Well, then my particle must be moving to the left between those two values. So from 3 minus root 5 to 3 plus root 5.